mole of an ideal gas undergoes a change of state from 2 atm 3 liter 95 Kelvin to 4 atm 5 liter 245 Kelvin with a change in internal energy of delta U equal to 30 liter atmospheres. The change in enthalpy for the process in liter atm is enthalpy H is related to internal energy by this equation. In this process, both pressure as well as volume changes during the process. So, delta H for this reaction will be equal to delta U plus P2 V2 minus P1 V1. So, this will be equal to 30 liter atmospheres plus P2 V2, that is 20 minus P1 V1, that equal to 6, equal to 30 plus 14. This is equal to 44 liter atm. So choice E is the correct answer. Given that 2CO plus O2 gives 2CO2, delta H0 equal to minus pKj, C plus O2 gives CO2, delta H0 equal to minus qkj. Enthalpy of formation of carbon monoxide is, the equation required is carbon combining with half molecule of oxygen forming carbon monoxide. The enthalpy of this reaction is called as enthalpy of formation of carbon monoxide. We have to get this equation from the given two equations. So this is the first equation and this is the second equation. So using Hess law, we can add, subtract, multiply, reverse, etc. for thermochemical equations. So the first thing that we require is the carbon atom. So carbon atom comes in the second equation, and carbon atom comes in the second equation. So we need not make any change for the equation. So simply we can write it out. C plus O2 gives CO2. Delta H for this reaction is minus Q. As a product we require carbon monoxide. Carbon monoxide comes in the first equation as the reactant. So for equation 1 we have to do two things. One, we have to reverse equation 1 and then divide by 2. So we will get the equation CO2 gives CO plus half O2. Delta H will be, when you are reversing, the minus P becomes plus P. When we are dividing by 2, it becomes P by 2. When you are adding these equations, CO2 and CO2 will get cancelled. C plus O2 gives CO plus half O2. Half O2 is taken to the other side. You get C plus half O2 gives CO, the required equation. So enthalpy will be minus Q plus P by 2. So you take LCM. You take LCM, it will be minus 2Q plus P. Minus 2Q plus P. So it is P minus 2Q by 2 is the correct answer. An ideal gas does the work of expansion solely at the expense of internal energy. The process is. So here the energy required for the expansion work is taken from the internal energy because the system cannot absorb heat from the surrounding. So such a system is called as an adiabatic system. So adiabatic system. Isothermal reaction take place at constant temperature. At 25 degrees Celsius and 1 bar pressure, which of the following has non-zero delta H of 0? thermodynamics, according to the convention, the standard enthalpy of formation of all elements in the standard state will be equal to 0. So, bromine liquid is a standard state, so this is equal to 0. Carbon graphite is a standard state, this is equal to 0. Ozone is not equal to 0. For this is oxygen is the standard state. So, ozone it is not equal to 0. Iodine solid is equal to 0. So, the correct choice is C, which is not having a non-zero delta H of 0. 1.8 gram steam at normal BP of water is converted into water at the same temperature. Delta H in kilojoules and delta S in joules respectively will be. You are given delta H vaporization of water is 40.8 kilojoules. Here you are given enthalpy of vaporization. This is equal to 40.8 kilojoules per mole. Here the process is steam is converted into water. So it is the reverse process. For the reverse process, that is, it will be equal to minus 40.8 kilojoule per mole. Here you are having only 1.8 gram steam. So delta H for this process will be equal to minus 4.8 kilojoules. So this is one answer. Secondly, you are asked to find out delta S in joules. Delta S will be equal to delta H by temperature. So this will be minus 4.08 by temperature is the boiling point of water, 373 Kelvin. This value will be obtained in kilojoules. You are multiplying by 1000 to get the value in joules. So the answer that you are getting is C. 4.08 is the delta H and minus 10.93 is the value obtained by simplification. That is the value of delta S.